The similar triangles lesson today. So you're going to be using your knowledge of ratios and proportions from, maybe elementary grade 9, and you're going to investigate something called similar triangles today. And if you, once you have a good understanding what similar triangles are, you're going to actually solve some problems like finding the missing side or and so forth. Okay. So similar triangles are triangles that are proportional to each other. So you should have the same angles inside, but one might be double, triple, or half the size of the other one. So like these cats, they're similar. Okay, they're the same cat, but they're different sizes, right? So it's an enlargement. So maybe it's like double the size of this cat, and so forth. So I'm going to show you a video um, where it's just shown really visually what similar triangles are.
Triangles are similar. Two triangles are similar if their matching angles are congruent and if the ratios of their matching sides are the same. So we just said we needed angles and sides to be the same. Let's talk about the angles first. Remember that the angle measures of a triangle don't change when the size of the triangle changes. The three interior angles of the triangle are always going to add up to 180 degrees. So the angle measures of these similar triangles are both 45, 80, 55 in that order. Now let's talk about sides. In order for the triangles to be similar, the triangles don't have to be exactly the same size, but they do have to be proportional. So if we know that these side lengths are 3, 4, and 5, and this triangle is double the size, then its side lengths have to be 6, 8, and 10. In other words, if we take the 3 side lengths of one triangle and match them up with the associated 3 side lengths from the other triangle, then we should be able to reduce each fraction to the same ratio.
Similar triangles, they have the same angles. Okay, so if we're looking at this diagram here, you can tell that the triangles aren't the same size, but if you look at the angle symbols here, this angle equals that one, this one equals that one, and this one are equal, okay? So that's the one condition, all the angles are equal, but the sides are going to be proportional to each other. So basically, if you were to match up each corresponding side, so like the bottom here is 14, the bottom here is 7, okay? And then we're looking at the bottom here, 6, so the side is 6, the side is 12. So hopefully you can see that there is a number. Like if you don't want to think of it as fractions, you can think of it as, okay, what times 7 would have made 14? What times 6 would make 12? So you're seeing that 2 is the same number. So knowing the relationship between the sides, okay, how they're proportional to each other, you should be able to predict this last side here. So that's what we're going to do today, but I just want you to kind of get used to the terminology and just how you write everything out. So the similarity symbol today, you are going to write this here. It's kind of like a little squiggly line and so forth, okay? So again, you have to write it like that. There are other symbols out there where if it's a squiggly and an equal sign, it's something else. So I don't want you guys writing that. Just write the little squiggle here, okay? All right. So from there, I know it has them both here. So just like here, the angles are equal. So that's why like I'm trying to show you that this means equal, okay? Like congruent, and it just means that they are similar. They're not the exact same, but they are actually equal, okay? But here we're going to say similar because they are, similar to each other, but they're not exactly the same here. Okay, so we can set up this ratio here where it's like, well, A to B, which is here, A to B is stacked on top of D to E because they form a relationship here, okay? B to C, okay, stacks up with E to F because those two are related. And then A to C stacks up with D to F, so to make these proportional relationships here. All right, so I have the ratio of the sides here, and then these are the conditions for similarity. So basically, if you don't have all of the information, if you know the 3 sides, and then you know that they're proportional, you can say, oh, these triangles are similar. If you have a side angle sides, you have side and then this angle and that side, you can also say that they are similar as well, because once you know that they are similar, you can use this proportional statement and so forth, okay? And then if you have two angles, you know that the third angle has to, you know what the third angle is because you know the angles are equal, okay? So, all right, so that's just the kind of the background information on similar triangles. We're just going to jump right into an example and it'll make better sense, all of these rules here. Oh, one more thing here. If you were going to make a similarity statement to say, oh, these triangles are similar, then you're going to say, well, triangle ABC, right, and then triangle DEF, they are similar triangles. So that's what this means here. And the statement says that they're similar, so you would say that these triangles are similar triangles, so therefore that means all the angles are equal and the sides are proportional, okay? So that's what we're trying to say here, okay? So all the angles are equal, the ones that correspond to each other, and then all the sides are proportional. So you know that they are related, but they're like one's double or triple, or it might be a decimal number greater than the other one and so forth, okay? Okay, so we know, so this is example one. We know that the triangle ABC is similar to triangle DEF. Okay, so that means we can write this similarity statement here. Okay, so knowing that, so then we know going in that the angles will be the same, and the corresponding angles, and then the sides will be proportional to each other. Okay, so part one, A here, we're going to look at finding the similar angles. So, so if you see right away in this diagram, you already see that one's already labeled. So you can say angle C is equal to angle E. Okay. That, and then we can do the similarity statement as well. So basically they're equal. I'm okay if you just write equals like that. All right, and then from there, so see how it like the way that you write this matches everything up. So A, B, C, right? So A and D. So see how D comes first in this one. So A and D are similar, okay? And then B and E go together, and then C and F go together. Okay, so angle A, even though we don't know it, we know that these triangles are similar. So we could say angle A is equal to angle D in the other triangle. And then the last one, angle B, is equal to angle F. Okay, and again, it all comes down to our similarity statement here. Okay, all right, so then from there, we know that the sides are proportional. Okay, find the similar sides and create ratios. So again, so if I have a side AB in the first triangle, which one is the same one in the other triangle? Well, DF. Okay, so that's, and then so they're proportional, so we're going to stack them into a fraction here. All right, so we'll do AC now. Doesn't matter which order, but AC and goes with DE. All right, and then BC goes with FE. Okay, I wrote the first one, the top one, A, B, in alphabetical order, and then I just make sure I match the letters at the bottom with the other triangle, DF. So AC became DE, BC became FE because B and F match up, okay? Okay, so now that we have our proportional statements here with the sides, the side ratios, what we're going to do now is we're going to go through and fill in the information that we know, okay? So we have AB, A to B is 3.3, okay? D centimeters, DF, we don't know, so we can call that DF, or we can call it X, I guess. We need to find that. So we can put it on here, X. All right, AC is 2.4. DE is 1.2. And BC is 3.7. And FE is 1.85. Okay. All right, so we have our proportion statement here. So because these are similar triangles, all of the sides have a relationship to each other. So we're going to look at, comparing the pairs that we do know, like the AC to DE, or the BC to FE, we should be able to figure out what the relationship is here so we can figure out the last side here that's missing, okay? So let's do that now. So if you wanted to look at just this one here, so 3.3 and 2.4, we can do that, okay? So if you take a look, 2.4, if you divide it by 1.2, they're double, it's double, okay? So you know that, if you go up like this, or, you can go down, I guess, you are dividing by 2 to get to here. So that's what you need to do here. You need to do the same thing. You divide 3.3 by 2, and you get 1.65. So x is 1.65, like that. Okay, all right. And again, if you don't like doing it this way, you can always just solve for it as well. Which we've done. So remember, if the x is at the bottom, we'll flip them both. Okay, and then we'll solve by kicking this over here. So right now it's divide, so I'm going to multiply it over. And then divide by the 2.4. And when I do that, I'll get x is equal to 1.65 as well. Okay. So now that we've seen that with this pair, okay, you can also make the same relationship with the other pair that we knew. Okay, so we also knew that, the BC to FE, we knew that relationship too. So if you divide it by 3.7 by 1.85, you'll get 2. So again, to go from here to here, I'm dividing by 2. So to go from here to here, I divide this by 2. So x is still 1.65. Okay, so that's how the similarity, and then write your units, centimeters. Okay, so that's how similar triangles work. You know that they are similar, the angles are the exact same, but we just have like a much bigger triangle here that, in this case here, it was double the size of the little one here. Okay, and because we know that they're similar, we know that the sides will always be proportional to each other, and so we can now find the last missing side. So with this example here, we knew the ratios for a couple different pairs of size, so we could use either of these ratios here to find our missing one here. So that's why I wrote, for the first one, I paired up these two together, right? For the second one, I paired up, this one and this one together, okay? So that's why you can just pick and choose. But sometimes you're going to find today that you only know one pair of the ratios, and so that's what you're going to use to find the other stuff, okay? So you might have that 2 sides are missing, but you know the one side, one pair, okay? So we'll go on to example 2 now. So we know that the triangle ABC is similar to triangle ADE, okay? So we know that they're similar. So right away, what are we thinking? We're thinking all the angles are the exact same. Okay, if the corresponding ones, wherever this angle is, it's in that other triangle in the same spot, that angle will be the same. And and then the sides are proportional to each other. So we know that, maybe it's double, triple, or, times 0.23 of the other side. Okay, so we know there's this proportionality relationship here so we can make the, the ratios. All right, so students in the past have found that, sometimes drawing these separately just helps them visualize better. So that's what we can do here. So I'm going to just separate this little one out of the bigger triangle here. So, and then relabel it. So here's the little one. I'll try to draw it as close as I can to scale here. So here, this was A, C, and B. Okay, and there's a right angle here. And then if we draw the big one now separate, so this one's called ADE, okay? And we know that these are similar. ABC is similar to ADE. Okay, so you can see how, because we have a right angle in both of these corners, those angles are the same. All right, and then on top of it, we have these dots to show you that these 2 angles are the same. All right, and then from there, we can label everything else. Like we know this is 3 centimeters. We know this is 6 centimeters. Okay, but then here's the tricky part. So this side here of the little triangle is called x, okay? We don't know what it is. We have to find it, okay? Find x. All right, but the big triangle here, okay, so if you were to cover up and ignore the little one, the big one here is x, and then it goes 4. So it's saying that from here to here, it's x, and then for the rest of the way, it's 4 centimeters. Okay, so that's what we know right now. So we know from here to here, that's the measurement of x centimeters. Okay, and then for the rest of the way from here to here, it's 4 centimeters. Okay, so those are the clues that we're given. Now from there, we have to, find the missing side. So we know that they're similar. So that means, if you really wanted to, fill in all the other details, you could say that, oh, well, if I know that they're similar, then I know that, this, I don't know, what should we use here? We can use an open circle, I guess. This angle and this angle are equal, because that's the whole definition of similar triangles. All the angles should be equal, okay, that one, and those ones correspond, okay? So, you don't have to do this, but you can kind of make a little statement here just to remind yourself, okay, A is equal to A, all right, in each of the triangles here. Angle B is equal to angle D, and angle C is equal to angle E, okay? All right, so anyway, we don't need to find the angles, but just wanted to re-explain here that those angles are the same. All right, so we need to find this missing side. So what we're going to do is we're going to make our proportional statements here of the sides. So A to B is the same as A to D. A to C is proportional to A to E. And the last side, B to C, the bottom, is proportional to D to E. Okay, so we know that this is much bigger. We're trying to figure out how much bigger it is, okay? All right, so once we know that, let's fill in all our information here. So A to B, that's what we have to find, so that's x. A to D, well, how would you write something that says from here to here is x, and then from there to there is 4? Okay, so how would you write that to represent that? Well, so if we know that x is 2, so if we knew it was 2, how long would this side be? Well, you would go 2 plus 4 is 6, right? So you know that you have to add whatever this x value is here, okay, to 4 to get the whole length of that side. So A to D we're going to represent as x plus 4, okay? All right, A to C, well, we don't know it. Do we need to find it? No, so I'm just going to leave it as A to C, okay? A to E, same thing, don't know it, don't need to find it. B to C, 3 centimeters, and D to E is 6 centimeters. Okay, so we filled in everything that we could find from the diagrams. We don't know anything about this ratio here, so we're just going to remove it and just write the expression like that, okay? So we know the top and bottom of this ratio, so we're going to use this to help us figure out what's going on here, okay? All right, so from here, I know a lot of you might try to guess and check and see if it'll work and so forth, but I want you to use your skills that you've picked up this year. Try to solve your way out of this, okay? So how do we do that? Well, let's just kind of get it out of this fraction form here. So I'm going to move, I don't know, let's move this whole bottom part. So it's divide, let's move it over here multiplied, okay? So when in doubt, just try something, just so you can see a different perspective of the question. Okay, and then I'm gonna move this fraction this way. So I know it's not really the solving rules, but we're just trying to get it so it's not looking like a fraction. So I guess if you wanted to find the common denominator, you can kind of get rid of the 6, but this is kind of awkward here. So I'm just gonna move it over here. It's allowed, right? It's divided, now I'm multiplying it. The 6 is divided, I'm gonna multiply it over here. So it becomes 6x equals 3x plus 4, like that. Okay, so that looks a lot nicer. And now you can kind of get it. There's no fractions, and so you should be able to expand things out, collect like terms, and solve for x, okay? So let's just do that. So this 3 here will multiply into both of these here. Okay, and then now we got, okay, we'll move the x's now back together, okay? I know like above here it was weird because I moved them away from each other, but it was just too hard to solve that right now. So, Okay, so now I'm going to move this here. We have subtract 3x equals 12, which was left behind. Okay, and then we want x by itself, so we'll take that 3, we'll divide it from the 12, and then x becomes 4. Okay, all right, so just because you got your answer, you're not done yet. You want to, um, you know, so you know what the x is now. It's 4, and you can say now that, oh, this whole side here is 8, and so forth. Okay, so therefore, x is 4 centimeters, right? Centimeters, yeah. Okay, so just make sure, I know that you probably could use a different way of going about doing this and so forth. Just make sure you show your work. You don't have to sit there and write all these letters out. If you wanted to just like go right into like plugging things in like that, I'm okay with that, okay? Just show some work and then tell me how you found X and so forth, okay? But in the end, we knew that we could set this up because you had an understanding that these were similar. Okay, so we know that the sides are proportional to each other. We know the angles are equal. So just I know there's lots of different ways you could probably have guessed and checked this and figured it out, but just understand that you're dealing with similar triangles here, and therefore that's why you can make this relationship up here. Okay. All right, last example here, and then this one here, it requires you to find a couple different variables. So yeah, it's probably the hardest one, but then if you can do it, then you're good to go for today. All right, so we have a triangle ABD. So where is it? ABD is similar to triangle ECD. So see how the letters are like the first set of letters is alphabetical, A, B, D, and then the second triangle, it just has to match the A, B, D. So A is the same as E, so that's why you say E, C, D, okay? C and B are the same, so the second one doesn't have to be in alphabetical order when you describe the triangle, it just has to match the first triangle that you stated, okay? So the first one, alphabetical, second one, just write it so it matches the first triangle. All right, so ABD is similar to triangle ECD. All right, so now that we know that they're similar, can you find the similar sides and create ratios and then determine the values of x and y? All right, so again, some of you are very visual, so you can kind of see the triangle easily and it's fine, okay? If it's a little bit trouble, causing trouble finding what you need from the triangle, what I want you to do is draw them separately. So I'll try to draw the little one here. Ooh, a little bit off. Okay, so we have E to D and I can C here, right? So we know this is 6 centimeters. So you want to draw them separately and then you want to draw write the details onto the triangles. We know this one's 3.6 centimeters. Okay, we have these arrows. That means that they're parallel lines. Okay, so that's going to be, so there you go. All right, and then I'm going to draw the bigger one now. It's a little bit off too, but anyway, this is A, D, B. Okay, so what do we know? We know that this bottom part is called X. We know that from here to here is 8. From here to here is 6, okay? So I'm just going to write those on. And then here to here is 3.6 centimeters, and this is y. So just wanted to point out that from here to here, that's 8. From here to here, that's 6, okay? And then from here to that corner, that's 3.6, and then the rest of the way is y. Okay, so just as you're setting up the, the equation so forth today. All right, so I'm going to write the letters out. You don't have to, but I'm just going to write them so you know exactly where to put them in the equation, okay? So let's start with, I don't know, C to D, okay? C to D here. So that's the same as B to D in the bigger triangle. Okay, all right, the bottom. So it doesn't matter which order you write them, but C to E, let me do the bottom here. C to E is similar to B to A. Okay, and the last side, D to E, is similar to D to A. All right, so now we have our ratios here. Let's fill in the values. So C to D I know is 6. B to C, so C to D, B to C. So see how you have 8 to here, 6 to there. So hopefully you see that, oh, the total is 14 centimeters, okay, for this whole side here. Okay, so that's 14 right there. All right, and then C to E. C to E is the bottom. We don't know it. So I'm just going to write in CE. The reason why I do this is because I know my goal is to find X and Y, okay? I don't want to start putting in extra letters and then I might get confused and think, oh, I got to find X or no, Z and M and S and all these other letters that you throw in. So just keep it a C to E so, to remind yourself that, oh, I don't have this side. I don't need to find this side. All right, B to A. Oh, actually, we need to find that side, okay? All right, and then, oh, actually, sorry, we have this side. I forgot to write it down. Okay, so all that stuff I just said, you know, if you're trying to find a side, if you don't need to find the side, write the letters in. Still do that, okay? All right, C to E we know. B to A we don't know. We're calling it X. D to E. D to E is 3.6. All right, and then D to A. So taking a look here, so from here to here is 3.6. The rest of the way is Y. So you can write this as 3.6 plus Y, this whole side here, okay? All right, so that's 3.6 plus Y. Okay, all right, so our goal is to find X and to also find Y. So lots of stuff going on here. All right, so that's like part A. So now we're going to do part B. We're going to solve for Y. Okay, so we know this one. So we know the top and bottom. So that's kind of like, I don't know, you can think of it as like the key to open the box and so forth. Okay, so this is what we need. We need the one that has both. Like up here, we had both this one and this one. So we used this one to unlock this, okay? Mystery here, I guess. Here we didn't know it, so we just got rid of it. We didn't need to use that. So that's what you're going to do here. You're going to use this one to find this, okay? But you're going to also use this one to find this one. So you can write both of them, both expressions, and then use them, solve them, okay? So we have the first one here. The first equation is 6 divided by 14 equals this this second one here, 6 over x. Okay, so that's the first, so this is to find x. All right, we also want to find y. So to find y, we're going to set up this equation. So again, we know the 6 over the 14, okay, and then equals this here. Okay, so I know I write all three of them together like that, but you can break them up so you only write them in pairs. So this 6 over the 14 is going to help solve both of them, okay? Because we know the top and bottom, and we know that it is equal to this. We know the top and bottom of this one, and we can equal to that, and so we don't have to write all three in here. All right, so we're going to solve this one for x, solve this one for y. Okay, so we have both of our letters at the bottom, and we've seen this already this year. So whenever we have that, it's kind of annoying to solve our way out. So we're just going to do a quick trick right at the beginning. We're going to flip them both. And it's allowed as long as you flip them both, okay? So you flip them both like that. And then from here, you're just going to solve here. So I know you could have seen, oh, I know what x is. It's like, show me right there. 6 over 14 is 6 over what? 14, right? But anyway, just pretend if you were just to practice solving. Okay, so we're going to flip them both. So you can think of it as like you're going to move this x here, multiply it over here. So you get 14 times 6 divided by 6 equals x. Well, those 6's cancel out. So x is equal to 14. Okay, and what are we at? Centimeters? Centimeters. Okay, so that one's easy, right? So kind of the same idea, solve your way out. So again, we have a y at the bottom, so let's flip these. So it's a little easier to manage. Okay, all right, so we want y by itself. Right now there's a 3.6 divided, so I'm going to multiply it over here. So right now it's divided, multiply it. All divided by 6, oops, 6 equals 3.6 plus y, okay? All right, so from there, you can go ahead, I guess, and multiply out the stuff there on the left. So 14 times 3.6 divided by 6 is 8.4. Okay, equals 3.6 plus y. All right, so last step here, let's move the 3.6 over. So 8.4, subtract 3.6, and you end up with 4.8 for y. Okay, all right, so you went through and you set up the ratios because you know that they're similar triangles, and from there you solved, you set up the equations because you know the proportional statements here, and then you just, solved your way through. Okay, so this one's a little trickier because it had a 3.6 plus y, but we know, hey, we just flip it up, right? We get the variable to the top and then it's easy to solve our way through. Okay, so nice slight lesson, I think. So just please practice like this one with the x and y. That's the toughest one you should see. Okay, a lot of them will be actually like this one where you're just trying to find the last side, but you'll see some like this. Okay, but if you can confidently do this one here, then you're good to go for today. Okay, so do some practice still and then try the checkpoint.